Hi everyone, welcome back to PULLAS Academy. This is physics class for ECET students by Kiran Kumar Adarapu. Today we are going to discuss about part 6 video in kinematics. In this video we will discuss about the motion of a body projected from the top of the tower. Okay, now this is today's topic. Okay, now here we will discuss mainly what is the expression for the height of the tower. So we have to understand what is the taken time to reach the ground when you projected one body from the top of the tower. So these two parameters for this body is very important. That's why we have to discuss height and time equations. So clearly from this concept here, this is also previous repeated area. That's why we have to concentrate on this topic. Listen carefully, all of you. Okay, right. So let us discuss about the expression for height of the tower. First we are going to construct the expression for height of the tower. After that we will discuss some special cases on this concept. After that we will discuss some different numericals based on this concept. Okay, right. So first, what is the expression for height of the tower? So in this way we have. So first we have to consider one tower. Okay, we have to consider the height of the tower is h. So after that we have to construct one expression. Okay, so that's why I want to consider this is a ground. Suppose I want to consider this is what? Ground. So on this ground, suppose this is called as one tower. This is what? One tower. The height of this tower is, we have to consider small h. Small h is the height of the tower. Clear? Right. So when you projected one body, so now we are going to construct, this is called as a tower. I consider the height of this tower is small h. Okay, now we need to construct the expression for height of this tower. So this is a very important concept on the height of the tower. So suppose if you consider one body of mass m, suppose when you projected this body upwards from the top of the tower, this is the top of the tower. From the top of the top of the tower, one body is projected upwards. When it is projected upwards, this body moves along vertical straight line upwards. So when it is moves along vertical straight line upwards, its velocity gradually decreases. At a certain height, its velocity becomes 0. That is the maximum height of this upwards projected body. Suppose at this point its velocity becomes 0. Suppose this body velocity is 0. When velocity becomes 0, then this body does not moving upwards. Okay, after reaching this certain height, because here velocity is 0. So then when its velocity becomes 0, then this body is now behaves like a freely falling body. So due to the gravitational force, this body is moves towards the ground. So that's why now this body is again moves along this vertical straight line downwards, and it is moves along moves in this way. But suppose it reaches to the same point, so this is not the resting position of this body. Why? Because there is no any place here. That's why here when it comes to here, also gravitational force is acting on this body. So that's why this body is not a resting position. That's why this body is again moves towards the ground, and finally it reaches to the ground. In this way, when you projected one body upwards, then it is moves along vertical straight line upwards and reaches to the maximum height. And after reaching maximum height, now this body velocity becomes 0. That's why now it is considered as a freely falling body. That's why it is again moving along vertical straight line downwards and finally reaches to the ground. It is strikes on the ground. Final position is on the ground. Initial position is at the top of the tower. These are the two important points. For this body, what is the initial position? At the top of the tower. What is the final position? Here on the ground. So these are the important points. So now we are going to construct the expression for this height of this tower. Okay, so in this way you have to consider one body is projected upwards. Projected means what? Here we applied some external force. Due to this external force, here given a initial velocity. At a initial position, given velocity is initial velocity. That means here we have given one velocity at this initial position, that is initial velocity. I consider u, it is projected with initial velocity u. So when you projected with velocity u, its velocity gradually decreases. Here velocity becomes 0. Again it is moves towards the ground. So then when it is reaches to the ground, its velocity becomes maximum here. Here velocity u, and finally here also its velocity maximum, or we have to consider that velocity, we have to consider v. In this way you have to consider. So one more point, when you projected this body, this is moves away from the ground. So actually, so velocity is gradually decreases. That's why, so when velocity is gradually decreases, then it has a negative acceleration. So this acceleration is getting by the body due to the gravitational force. That's why that is always similar to the acceleration due to gravity. That's why we have to consider for this body A is equal to minus z. It is also one of the upwards projected body. Just the difference is what? It is not projected from the ground. It is projected from the top of the tower. That's the difference. Everything is same. Okay, now that's why here its acceleration is minus g. Okay, now, and one more point, this is the initial position, this is the final position. What is the displacement of this body? H is the displacement of this body. So what is taken time to reach the ground when you project it from the top of the tower? I consider t. Okay, now we need to construct the expression for t and h. Okay, now we are going to construct that equation. Listen carefully. It is derivated by using the second kinematic equation. We know that equation. We know that from the second kinematic equation, from the second kinematic equation for uniformly projected body. What is the equation here? That is S is equal to ut plus half at square. This is for uniformly projected body, second kinematic equation. Here S stands displacement, U stands velocity, initial velocity, T is the taken time, A is the acceleration. For this upwards projected upwards projected body from the top of the tower, what are the known parameters? I consider one is initial velocity U. First you have to write that known parameters. One is initial velocity, always indicated by U. Here also we consider U. So that's why here known values, initial velocity of this body, we consider U. Okay, na? Right. Next, the second parameter is what? Acceleration. What is the second parameter? Acceleration. So acceleration is considered minus. When any object moves away from the ground, takes minus. Otherwise moves towards the ground, takes positive sign. So it is under the influence of gravitational force this body is moving. That's why this uniform acceleration is similar to the acceleration due to gravity. That's why it is similar to small g. Why using negative sign already I explained in the previous video clearly. So just understood here A is called minus z. Next, one more parameter is displacement. This is very important. Listen carefully. What is displacement of this body? Displacement S is equal. So this is the initial position, this is the final position. Initial position on the top of the tower, final position is on the ground. Actually it is projected upwards, but it displaced downwards. That means here it displaced in the opposite direction of projected body. That's why initial and final position minus initial position is called displacement. Displacement stands the straight line distance, the straight line shortest distance between initial and final position is called as displacement. Between initial and final shortest distance is h. But here in the opposite direction, actually we projected upwards but it displaced downwards. That's why we have to consider minus h. Okay, na? In this, if you can't understand in this way, you have to understand. For example, it is projected from this point. So this travel distance from the top of the tower. Suppose I consider small x upwards it is displaced, and again small x distance travel downwards. Okay, now it is moving upwards, that is plus x. When it the same body moving same distance in the downwards takes minus x, while moving upwards plus x, while moving downwards minus x, while moving from this top to ground also it is downward motion. That's why this distance is h, but it is moving downwards. Moving downwards I consider negative sign, moving upwards positive sign, because in vectors opposite direction always denoted by negative sign. Don't confuse here, this is minus x, that means plus x minus x cancel. What is remaining here? Minus h is the displacement. Don't confuse here, for this body what is displacement? Minus h. In this one understood? Okay, next here we have to consider one more expression, that is time t is equal to t. Okay, now these all are the parameters. Substitute in the equation, you get the expression for height of the tower. So now substitute, instead of s is equal to minus h. Okay, now next instead of u substitute u, t instead of t substitute t, same. Next plus, instead of a what? Minus g. Instead of t write t square. This is minus h is equal ut plus half into minus g into t square. If you simplify this equation, listen carefully, minus h is equal to ut write as it is, plus into minus minus half gt square is the formula. Okay, na? So again simplify this equation like this here. Suppose in this equation negative sign is take common, you get minus ut plus half gt square. If you take negative sign is common, you get minus into minus plus, minus into plus minus. That's why it is similar. So if you take negative sign, then this negative sign cancel. What is remaining? H is equal minus ut plus half gt square. This is a most important expression in this video. This is the most important expected expression and most important equation, that is h is equal to minus ut plus half gt square. This expression stands height of the tower. Height of the tower when the body is projected upwards. When the body is projected upwards, height of the tower formula is what? Minus ut plus half gt square. G is a known value. Just you know what is projected velocity, what is taken time to reach to the ground, then substitute in the formula, you get what is the height of the tower. This is a procedure to measure the height of the tower. I hope you understood. Clear? So this is the expression for height of the tower, that is h is called minus ut plus half gt square. So in this equation t stands taken time to reach the ground. From this equation directly measure what is h value, u value, substitute, you get t, g is the known value. So find out the t value, that is called as taken time to reach the ground. So suppose otherwise if you want to the expression for t, so you want to expression for t means what? As a subject t, what is expression if you want? So we have to derive from this. If you simplify this equation, you get the expression for time taken to reach the ground. How to write here? If you observe this equation, so this equation write like this. This half gt square means what? G by 2 into t square. Remaining is minus ut. This h is shifting into right side, that is minus h is equal 0. So this equation stands one of the quadratic equation. If you observe clearly, what is quadratic equation? Ax square plus bx plus c is equal to 0. It is like a same equation. Instead of xt, so here a means constant, its constant is z by 2, b is equal minus u, c is equal h. If you compare to this equation, understand what is, we need expression for t. We know the what is the expression for x. What is the solution of x for quadratic equation? That is x is equal minus b plus or minus under root of b square minus 4ac by 2a. It is in the mathematics, you know this equation, that is the solution of quadratic equation. plus or minus under root of b square minus 4ac. In the same way, if you compare to this equation, you get x instead of x, you get t. That means you get the expression for t. How to get here? Compare to this equation, a is equal g by 2, and what is b is equal minus u if you compare, and c is equal to what? Minus h. Substitute these all values, then t is equal minus b. Minus stands what here? So minus b. B stands what here? Minus u. Minus u. Minus into minus u. Plus or minus. Only take the positive value. Time is measures positively. That's why there is no need to substitute negative sign. Just positive sign is enough. Plus into under root of b square. B into b means minus u whole square means plus u square. Next minus 4ac. 4 into a stands what here? A stands g by 2 into c. C stands what? Minus h is the formula. All divided by what here? Equation 2a. A stands what again? G by 2. If you simplify, you get it. So in this equation, minus into minus plus u plus under root of u square minus into minus plus 2 2's are, that means 2zh. Here formula is what? 2zh. 2 cancel. Finally you get g. So this expression stands the taken time to reach the ground by this body when a body is projected upwards from the top of the tower. So otherwise write u by g plus under root of u square plus 2zh by g square. So that's also similar. If you simplify this equation, you get different types. So this is a standard equation. If you want to conversion in any form, there is no problem. Mainly it's just u value and h value. G is a known value. You get what is taken time. Okay now. So this is the expression for time taken. This is expression for height of the tower. Just these two are the important expression in this concept. Now we are going to discuss some special cases on top of tower. One special case here, that is here this is the top of the tower. From this top of the tower, one body, this is a, suppose I consider this is the first, in the first special case one, this body I consider one. This is dropped freely from this top of the tower. Then what is the expression for height? That means this is freely falling body. Already in the previous video we constructed, that's why I understood directly. A body is dropped freely from the top of the tower. What is the expression for height of the tower? So here for this freely falling body, u is 0, a is equal to z. What is the next one? This it is displaced downwards and it is moving downwards. That's why s is equal to h. Okay. Next, this taken time I consider t. In the same equation, s is equal to ut plus half a d square. In this equation, if you substitute, that is s is equal to h. U is equal to 0 into t plus a is equal to plus g t square. That means h is equal half gt square. Already we have derivated. So from this equation, sometimes asking height of the tower, when a body is dropped from the top of the tower, use this formula. Not always use that formula. If the body is projected upwards from the top of the tower, only that equation. What is that equation? H is equal minus ut plus half gt square. Otherwise it is dropped from the top of the tower, use this formula. Okay now? Right. Now we are going to discuss second case, special case 2. What is special case 2? Listen carefully. This is suppose second body from the top of the tower. So this body is also dropped, not dropped, it is also projected vertically downwards with some velocity. That means what is the difference between these two? It is also moves along vertical straight line downwards. It is also moves along vertical straight line downwards. But it is freely dropped. But it is vertically downwards. It is actually vertical straight line downwards. It is projected with some velocity. That's the difference. That means second case is a body is projected vertically downwards, from the top of the tower. Top of the tower. So here the concept is what? From the top of the tower, if the same body is projected with some velocity, projected vertically downwards, okay, now projected with some velocity here, with some velocity along vertically downwards, that's the point here. Okay, now in this case here its initial velocity is not 0. In this case u is equal to u. It is also moving downwards, that's why is equal to x plus g. Here also plus g. It is moving downwards, displacement also downwards, that's why s is equal to h. And what is taken time, I consider again t. So then he uses second kinematic equation, s is equal to ut plus half at square is the second kinematic equation. In this equation again substitute s is equal to h, u is equal to u, t plus half gt square, u is equal to u. So and s is a is equal to plus g. This is a formula. Okay, in the first equation minus ut plus half gt square, but here plus ut plus half gt square. When the body is projected vertically upwards, minus ut. When the body is projected vertically downwards with velocity from the top of the tower, takes the positive sign. That's the difference. Okay, now one more case here. Third one is, suppose this is a body, it is projected horizontally with velocity u. What is the expression? So that means a body is projected with some velocity along horizontal direction, along horizontal. Okay, now along horizontal from the top of tower. That's the concept here. So here in this case, listen carefully. Along horizontal direction velocity is u. Along horizontal means x-axis, but along vertical direction its velocity is always considered 0. It is projected along this direction, that means along vertical direction is 0. Why? Because it is projected in this way, but it is not moving along this direction. Why? Because on this body also acting gravitational force. Due to the gravitational force, after some travel distance, this body also moving towards the ground and finally reaches to the ground. That means vertically it is displaced. Initial position top of the tower, final position on the ground. So along, that's why we have to consider these parameters. The parameters along vertical direction, we have to consider initial velocity along vertical direction is 0, not x u. Okay. Next, along vertical direction acceleration is considered g. Okay. Now in this direction it is also moves towards the ground, that's why plus g. Again it is moves towards the ground and displacement in the downwards, that's why s is called plus h. All in the vertical, when vertically projected upwards takes minus h. In all other cases we have to consider s is equal plus h. Again if you consider this time is t, if you substitute in the same formula, s is equal to ut plus half at square is the formula. Then s is equal to substitute h, u is equal to substitute 0 into t plus half, a is equal to g t square. Finally h is equal to you get half gt square. That means when you projected horizontally with some velocity, or when you dropped from the top of the tower, then you get the same equation. That means if you dropped any body from the top of the tower, or if the same body is projected horizontal with some velocity, they are reached to the ground in a similar time. Why? Because you get the same equation, there is no difference. That's why if you projected horizontally or if you dropped the body from the top of the tower, there is no difference. The two bodies are comes to the ground simultaneously. That's the concept understood from these two equations. Okay, now, but if you projected downwards with some velocity, or if you projected upwards with some velocity, this height equation and time equation is different. Otherwise, if in the for confusing question is asking, so if it is projected with some velocity along horizontal, there is no difference. Here asking height, use this formula. Height is giving, sometimes time is asking. Just two questions are possible, height is asking or time is asking. Here also height is asking, time is asking. Here also height or time is asking. So these all are the different questions on this motion of a body projected from the top of the tower. Okay, in this concept the important formulas are, one is for upwards projected body from the top of the tower, already we have constructed, that is h is called minus ut plus half gt square. So u is initial velocity, g is acceleration due to gravity, t is the taken time to reach the ground, h is the top of the tower. Otherwise, one more case here, for freely falling body from the top of the tower. From the top of the tower, if your body is freely falling, use this formula. Its height of the tower formula is half gt square. So for vertically downwards projected body from the top of the tower, if it is projected downwards with some velocity, use this formula. With this a small difference, minus plus here. Next, from the same top of the tower, a body is horizontally projected with some velocity, then also half gt square. In these two cases, height of the tower formula is same. So these all are the important formulas. You have to focus on these formulas. If you know these are formulas, if asking any question, you have to attempt very easily. After completed the topic, you have to revise like this. Okay, you have to remind these all important expressions in each and every topic. So you have to attempt the questions very easily. Must and should concentrate on the important formulas. Now we are going to discuss some previous ECET model questions related to projected body from the top of the tower. Okay, now first question. This question is repeated in ECET 2013 paper. What is question? From the top of a tower of height 39.2 meter, a stone is thrown vertically up with a velocity of 9.8 meter per second. How long will take to reach the ground? What is taken time to reach the ground? It is a question here. So what are the given values? First we have to write the given values. Given values is height of the tower is given, that is h is equal 39.2 meter. And one more is given, initial velocity is given 9.8 meter per second. What is asking? Time is asking. Which formula we have to use here? So it is projected vertically up. When projected vertically up from the top of the tower, use this formula. In this way you have to recognize. That's why formula is h is equal minus ut plus half gt square in the formula. Here in the formula g is not given because it is a known value. You have to substitute 9.8 meter per second square. Okay, now in the bracket given, take g is equal 10 meter per second square, substitute, otherwise always substitute 9.8. Now substitute h value is 39.2, u is equal to minus 9.8 into taken time. Here asking taken time t, write as it is. Next plus of g means 9.8 into t square. If you simplify, you get it here. So 2 cancel 4.9. Okay, now that means here 39.2 is equal to minus 9.8 into t. Next plus 4.9 t square is the formula. After simplification like this, here 4.9 is take common, you get t square. Here minus 2t. So 2 into 4.9, 9.8, it is shifting into right side minus, that is 4.98 is a 39.2, that's why here write 8 is equal to 0. That means here t square minus 2t minus 8 is equal to 0. This is one quadratic equation. If you simplify, you get t value. How to simplify here? T square, 8 means what? minus 40 plus 2t minus 8 is equal to 0. If you write minus 40 plus 2t is minus 2t, then t is take common, t minus 4 plus 2 into t minus 4, that means t minus 4 into t plus 2 is equal 0. That means t is equal to 4 or t is equal minus 2 is impossible. That's why t is equal 4 second is correct. Time is always measures positively. There is no, it is not possible to measure negative sign. That's why 4 seconds is the correct answer. So this is a previous repeated question. We have to find out like this. The next question is repeated in ECET 2010 paper. So from the top of a tower, a stone is projected vertically upwards with a velocity of 20 meters per second and it reaches the ground in 8 seconds. Small g value is 10 meters per second square. The height of the tower is asked. So same concept here. What is given values here? Given values, one is velocity. That means projected velocity u is 20 meters per second is given. What is taken time to reach the ground is 8 seconds. Small g value is here given 10 meters per second square. That's why substitute 10. So what is asking here? Height of the tower. In the previous question, time is given, time is asking, height is given. Here height is asking, time is given. That's the two types of questions here. What is the formula? It is also from the top of the tower, it is projected vertically upwards. For vertically projected body from the top of the tower, use the same formula. H is equal minus ut plus of 8 of gt square. Okay na? So then use this formula. Okay, maximum times asking when the body is projected vertically upwards from the top of the tower. These special cases are sometimes only, but here asking major question is asking on this. You have to concentrate here. Okay, suppose otherwise given from the top of the tower, drop dot is horizontally projected. So from the question you have to use a different formula. Okay, now don't use directly this formula. First read the question clearly. Is it projected vertical upwards or is it vertically projected downwards? It is horizontally projected or it is freely dropped. So then you have to use the formula. H is asking here, H is equal to ut, u is given 20 minus 20 into t is given 8 seconds. Next plus of g is given 10, t square, t is equal given what? 8 square is the value. Now here 28 is 160 minus 160, 2 5s. This is 8 square means 64. 64 5s is 320. That means 320 plus 320 minus 160 is plus 160. So what is the height of the tower? Is 160 meters. This third option is correct. The next question is repeated in ECET 2009 paper. The question is a stone thrown vertically up with initial velocity u from the top of the tower reaches the ground with a velocity 3u. The height of the tower is asking. Here also it is thrown vertically up. That's why. But here not time is given. Height is asking. Initial final velocity is given. That's why we have to derive one expression here. So for example, this is top. Listen carefully. This is top of the tower. It is projected upwards with velocity and reaches to height and finally reaches to the ground with velocity. These two velocities are given. This is the displacement from these 2 points is minus h is the displacement. Given values u is equal to u, v is equal to v, a is equal to minus z, it is projected upwards and displacement s is equal to minus h. So third equation is v square minus u square is equal to 2as. Here v is equal to v square minus u is equal what? U square is equal to 2 into minus g into minus h. Finally you get v square minus u square is equal to 2gh is the formula. Here h is asking, remaining all are given. H is equal v square minus u square by 2g. So this is the formula for height of the tower in terms of initial and final velocity. There is no need to, this is not need to write this derivation, actually just for your understanding. If you know this formula directly you have to substitute. Then h is equal to v is equal to given what here? 3, here given values v is equal 3v, u is equal to given u, that means instead of v write 3u whole square means 9u square minus u means u square by 2z is the formula. 9u square minus u square is 8u square by 2z. Okay, that 2 4s, that means height of the tower is 4u square by g. This is the formula for height of the tower. If initial final velocities are given, so in this way we have to construct the formula, you get this is also expression for height of the tower in terms of initial and final velocity. Okay, we don't know the time function, use this formula. These are the different model questions related to this topic. Okay, now you have to concentrate like these questions. Okay, thank you, bye, have a nice day.